This is a problem about electrochemistry. We're going to calculate the equilibrium constant from E. The question states, calculate the equilibrium constant for the following reaction at 25 degrees Celsius. Zinc 2 plus aqueous plus 2 Ag solid yields zinc solid plus 2 Ag plus aqueous. To solve this reaction, we use the equation E degrees cell equals 0.0257 V over N ln of K. We want to solve for the equilibrium constant, so we're going to solve for K. So to do this, we have to do ln of K is equal to N times the E degree of the cell over 0.0257 B. That's the equation we're going to work with. We have to figure out what E degree of the cell is. So to do that, we do E degree of the cell is equal to E degree of the cathode minus E degree of the anode. To find this value, you have to do a redox reaction and figure out which is your cathode and which is your anode. Your cathode is your zinc and your anode is your silver. To find these values, you have to look them up in your book or in a certain index where you're given the value of the E degree for the half reaction for each for each reactant. The E degree for zinc in this case is negative 0.76, and the E degree for the silver is 0.8. So you do negative 0.76 minus 0.8, and you get negative 1.56. So now that you have this value, your E degree cell, you use it in your equation to find for K. So you do ln of K is equal to N, which in this case is 2 because we have 2 plus over here and 2 Ag over here. So we're adding 2 electrons to this side and 2 electrons to this side to balance out the reactions. So N in this case will be 2. E degree cell, negative 1.56. And at the bottom we have 0.0257 B. We solve. We put these numbers into our calculator and we get negative 121. We want to solve for K, so in order to do that, we have to E this value. So we do E to the negative 121, and we plug that into our calculator, and we should get a value of 3 times 10 to the negative 53. And this is an approximated value. We round it to one significant figure, so our final equilibrium constant for this whole reaction would be 3 times 10 to the negative 53. And that's how you work out this problem.